And welcome to 6.1. When you consider that there are 11 units in this course, you're now in the downhill part of it. So this is great. This whole unit is going to be about identities. And I think we got to talk about what is an identity before we get started. So we've been playing around with equations for a long time. So if I was to present something like 2x plus 1 equals 5 to you, I guess I would say, could you solve it? And so what does it mean to solve an equation? To solve an equation, I'm going to put it this way, is to say what values of the unknown, in this case it's x, make that a true statement. So we could say, in this case, we could solve it by saying, I don't know, I guess it's x equals 2. So we could say that statement, 2x plus 1 equals 5, is true when x is equal to 2. How about when sine theta equals a half? So sine theta equals a half. We have to think a little bit. I'm going to draw my unit circle here, and sine on the unit circle is the y values. So if I said half is about there, so I think I've got two options. I got this one over here, and I got that one over there. So I could say that this is true when theta is equal to pi over 6. I'm going to do this in radians, and when it is equal to 5 pi over 6. So it's true in both of those cases. How about an identity? So an identity looks a little bit different. If I was to say to you, x plus x equals 2x, you might say, yeah, what are you asking, Mr. Spicer? So an identity isn't something that you can solve, but you can be asked to prove whether or not this identity is true. So essentially I can say that for all these identities, I'm going to try to make one of these neat little brackets there, they're always true. True always. But I'm going to put a little asterisk. Asterisk means like that, but there's a catch. Almost always. And so sometimes there might be a situation where it's not true. So is x plus x always equal to 2x? Sure, I think so. Is tan theta always equal to sine theta over cos theta? Like that's how we have defined what tan theta is. In fact, there are situations where that is not a true statement, and we're going to find that out. How about this one? X over x divided by x is equal to 1. Is that always true? Like if I put in a 3 over 3, 3 divided by 3 is 1. What if I put in an x equals 0? So if I put in a 0, I'd say 0 over 0. What is 0 divided by 0? If you have a calculator or if you put in a Google or something, you might get undefined, you might get infinity, but it's not necessarily 1. It's actually an interesting conversation about what do we think 0 divided by 0 is, but it's not 1. So x over x is equal to 1 is an identity, except for it's not true when x is equal to 0. So we could say except when x equals 0. So we could say that these are all identities. These are always true, and sometimes there are exceptions. And what we call those exceptions are going to be right over here, these non-permissible values. So an equation is true for certain values, and we can solve it by finding those certain values. An identity is always true except for non-permissible values. Here are some identities that we should know, and these are the basic kind of definitions of our trig. The tan of x is equal to sine over cos, and so on. I won't read them all out for you. Now I want to say on the bottom, non-permissible values, for trig anyways, are values that result in a denominator equal to 0. So that's the way we're going to be sort of figuring these things out.